Hello all, welcome to this lecture on different types of learning methods in AI. Let's start with supervised learning. So in supervised learning, the model is trained using labeled data. And over here, each input comes with a corresponding output or label. And the goal is for the model to learn the relationship between inputs and outputs so it can predict the output of new and unseen data. So labeled data is very important for supervised learning. Using labeled data, it tries to understand the relationship between input and output, and using that, it predicts the output for new data. Let's take an example. And in this example, the model is trained on a dataset of emails which are labeled as spam or not spam. Once the model is trained, it can predict whether the new emails are spam or non-spam. And the next learning method is unsupervised learning. In unsupervised learning, the model is trained on data without labels. The model tries to find hidden patterns, structures, or relationship within the data on its own. So let's take an example of a financial transaction. A model might analyze financial transaction data and identify unusual patterns like potential fraud without knowing beforehand what fraud looks like. So it will try to identify patterns, structures, and relationship, and it will try to tell us which transactions are fraud. Next is reinforcement learning. Reinforcement learning is a very important concept, and a lot of people believe that this is something which is going to take AI to the next level, and a lot of automation in the world of AI you will see because of this. Let's understanding more. So in reinforcement learning, the model learns by interacting with an environment and receiving feedback in the form of rewards or penalties. The model takes decisions or actions, and based on the outcome, which can be reward or penalty, it learns to make better decisions over time. Let's take an example which we discussed briefly at the start of this segment. In chess, reinforcement learning allows the AI agent to learn from its actions by playing many games, receiving feedback, and adjusting its strategies to improve over time. The ultimate goal is for the agent to develop a robust strategy that maximizes its rewards, winning the game as efficiently as possible. Now let's look deeper into this example and see how reinforcement learning cycle applies here, and what are the concepts involved in this context. Firstly, environment. The environment is the chessboard, including all possible positions of chess pieces at any given time. Agent. The agent is the AI that you are training to play chess. Its goal is to win the game by making a sequence of moves. States. A state represents a specific configuration of the chessboard. For example, the starting position of the chessboard is one state, and each subsequent move leads to a new state. Actions. Actions are the possible moves the agent can make from a given state. Next is policy. The policy is the strategy that the agent follows to decide which action to take in a given state. It's essentially a mapping from states to actions. And next, very important, reward. The agent receives reward based on actions it takes. For example, a small positive reward for capturing an opponent's piece, a larger positive reward for achieving checkmate or winning the game, a negative reward for losing a piece, and bigger negative reward or penalty for being checkmate. Lastly, the goal. The goal of the agent is to maximize its total reward, which in this case means winning the chess game as frequently as possible. And as we learned earlier, using reinforcement learning, an AI model was able to learn chess by itself in just 4 hours and was able to defeat the grandmasters of the world. So that's how powerful reinforcement learning is, and it is going to play a major role in future with many innovations coming through reinforcement learning. Lastly, let's understand what is self-supervised learning. This is a very interesting concept, and this is similar to unsupervised learning, but the data structure automatically labels the training data. Automatically labeling is very important, and it can help enhance the training process and provide insights. A very good example is large language model, which learns on huge amount of data which may or may not be labeled. For example, LLM is trained on data all around the world, and some of the data might be about how to code or how to write a piece of code. And LLM will learn on its own, and it will identify that this is Python code, this is Java code. And once it is trained, and once you ask it to write a program on Python or Java, and based on this self-supervised learning, it will give an output of generating code for Python or Java based on your input. So that's about self-supervised learning. So that's it in this lecture. I hope you like it. See you in the next one. Thank you. Bye.